Good morning, students. Myself S.C. Kunde from JDC Bitco English Medium High School, Nasik Road. Previously, we have discussed Doberinus triad, Newland's octave, Mendeleev's periodic table, merits and demerits of that. Now, the next topic is modern periodic law. The scientific world did not know anything about the interior of the atom when Mendeleev put forth the periodic table. After the discovery of electron, scientists started exploring the relation between electron number of an atom and the atomic number. The atomic number in Mendeleev's periodic table only indicated the serial number of the element. After that, in 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiment done using X-ray tube that the atomic number Z of an element corresponds to the positive charge on the nucleus or the number of proton in the nucleus of the atom of that element. This revealed that atomic number is a more fundamental property of an element than its atomic mass. Therefore, the properties of elements are a periodic function of their atomic numbers. Next is modern periodic table. The classification of elements resulting from an arrangement of the element in an increasing order of their atomic numbers is the modern periodic table. The properties of element can be predicted more accurately with the help of the modern periodic table formed on the basis of atomic numbers. As a result, most of the drawbacks of Mendeleev's periodic table appear to be removed in the modern periodic table. The relation between the atomic number of an element and its electronic configuration is clearly seen in the modern periodic table. Structure of the modern periodic table. In the modern periodic table, 118 elements are discovered. In that modern periodic table, it contains 7 horizontal rows called the periods 1 to 7. And the 18 vertical columns in this table are the groups, that is 1 to 18 groups are there. The arrangement of the periods and groups, they are in the form of boxes. Atomic numbers are serially indicated in the upper part of these boxes. Each box corresponds to the place for one element. That means one box contains one element. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table, and these are called as lanthanide series and actinide series. There are 118 boxes in the periodic table, including the 2 series. It means that there are 100 places for element in the modern periodic table. The periodic table is divided into 4 blocks: S block, P block, D block and F block. The S block contains group 1 and 2. Then 13 to 18, that is the P block elements. Then group 3 to 12, it is the D block elements. And the lanthanide and actinide series are present at the bottom of the F block. The D block elements are called as transition element. A zigzag line can be drawn in the P block of the periodic table. The 3 traditional type of elements can be clearly shown in the periodic table. All the metals lie on the left side of the zigzag line, while non-metals lie on the right side of the zigzag line, and all the metalloids are present on the border of the zigzag line. Modern periodic table and electronic configuration. Within the period, the neighboring elements differ slightly in their properties. Elements in the same group show similarity and gradation in their properties. This is because of the electronic configuration of the element. The electronic configuration of an element which decides the group and the period in which it is to be placed. Groups and electronic configuration. You will find that the number of valence electron in all these elements from the group first Group first, that is the alkali metals, is the same. What is the valence electron? An electron of an atom located in the outermost shell. It is called as the valence electron that can be transferred to or share with another atom. For example, the elements that is beryllium, magnesium and calcium belongs to the group 2. Now group 2 means the alkaline earth metal. There are 2 electrons in their outermost shell. So similarly, there are 7 electrons in the outermost shell of the elements such as fluorine, chlorine from the group 17. That is the family of halogen. While going from top to bottom, within any group, one electronic shell gets added at the time. Periods and electronic configuration. The number of valence electron is different in these elements. The number of shells is the same. Now, while going from left to right within the period, the atomic number increases by 1 and the number of valence electron also increases by 1 at a time. Now see in this example, the first element of this period, that is sodium. Electronic configuration of sodium is 281. Only one electron in its valence shell is present. While the last element of this period is argon, the electronic configuration of argon is 288. It has 8 electrons in its valence shell. Now see first period. In first period, 2 elements are there, hydrogen and helium. It is the shortest period and discontinuous period. Then second period, it contains 8 elements from lithium to neon. It is the first short period. Third period is also contains 8 elements from sodium to argon. It is second short period. As per the electron holding capacity of shell, 2 elements are present in the first period and 8 elements in the second period. The third period also contains only 8 elements due to the law of electron octet. Periodic trends in the modern periodic table. When the properties of elements in a period or a group of the modern periodic table are compared, certain regularity is observed in their variations. It is called the periodic trend in the modern periodic table. What is valency? You have learnt in the previous standard that the valency of an element is determined by the number of electrons present in the outermost shell of its atom, that is the valence electron. Next is atomic size. Atom is the smallest indivisible part of any matter. You have seen in the previous standard that size, volume is a fundamental property of matter. The size of an atom is indicated by its radius. Atomic radius is the distance between the nucleus of the atom and its outermost shell. Atomic radius is expressed in the unit picometer, which is smaller than nanometer. In the periodic table, zigzag line separates the metal from non-metal in the periodic table. Now, the metals are on the left side of the line and the non-metals are on the right side of the zigzag line. Metalloids are along the border of the zigzag line. Let us compare the characteristic chemical properties of metal and non-metal. It is seen from the chemical formulae of simple ionic compound that the cation in them is formed from a metal, while the anion from a non-metal. The metal atom have a tendency to form a cation by losing its valence electron, and this property is called as electropositivity of an element. On other hand, an atom of a non-metal has a tendency to form an anion by accepting electron from outside into its valence shell. We have already seen that ions have a stable electronic configuration of in noble gases. All the electrons in any atom are held by the attractive force exerted on them by the positively charged nucleus. Electrons in the inner shell lie in between the valence shell and the nucleus. Because of their presence, the effective nuclear charge exerting an attractive force on the valence electron is somewhat less than the actual nuclear charge. Let us first consider the metallic character of elements belonging to the same group. While going down a group, a new shell gets added, resulting in an increase in the distance between the nucleus and the valence electron. This results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electron. As a result of this, the tendency of the atom to lose electron increases. Also, the penultimate shell becomes the outermost shell on losing valence electron, and the shell is a complete octet, as the resulting cation has a spatial stability. Therefore, the following trend is observed. The metallic character of elements increases while going down the group. While going from left to right within a period, the outermost shell remains the same. However, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge goes on increasing. And as a result of this, the tendency of atom to lose valence electron decreases within a period from left to right. The increasing nuclear charge and decreasing atomic radius as we go from left to right within a period are responsible for increasing the effective nuclear charge. Therefore, the valence electrons are held with greater and greater attractive force, and this is called as electronegativity of an atom.